morning. It is almost April break. Are you excited? Because I am pumped. I am hoping to have a really nice week and look forward to being out in the sun and spending time with my dogs, my kids. So, solve radical equations. As with all the other things you learn, the whole reason we learn how to multiply and add radicals and variables is because eventually we're using them in an equation. And you're going to see us use that again in chapter 12. So, a radical equation, I'm just going to describe it up here, is an equation that contains a radical expression, which is everything we did in 11.2. With a variable in the radicand, as we saw in 11.1. In other words, you have an x or a y inside the square root. So just as with all other equations to solve for x, you're going to want to get x to one side. But there's a particular way to solve radical equations. And for example, if I have a equals b, I know that a squared equals b squared. It's just one of those rules. If this expression is equal and I do the same thing to both sides, then they're going to remain equal. So if two expressions are equal, their squares are equal. It's the same thing that we did before, right? If I add something to A, I have to add the same thing to B. If I subtract something from A, I have to subtract the same thing from B. If I multiply something by A, I have to multiply the same thing by B because I have to keep this equation balanced. So the same thing works with squaring and square roots. So this allows me to do the following. If I end up with a square root of x where I have a variable in the radicand, how else am I going to solve for x, right? How do I do that? Well, you've seen some of this when we did, chapter 10. The opposite of a square root is squaring. So to undo a square root, you square. And whatever I do to one side, I do to the other. And so the square root of x squared just leaves x. And I end up with 3 squared is 9. So x equals 9. This is a very, very powerful tool, and we're going to use it quite a bit. So let's start with example 1. If I have 2 square root of x, actually I'm just going to put an x in there. I was going to put something more, but the negative 8 is outside, equals 0. Well, the first thing I'm going to do is I want to solve for x. And so I need to add 8 to both sides. And I end up with 2 square root of x equals 8. Well, I am still not quite there because I still have something crowding the x. It's inside the square root, but I still have 2 crowding the x. So my next step is to get rid of the 2 by dividing both sides by 2. When I do that, I end up with simply square root of x equals 4. Well, now I'm almost there, and I just want to undo this operation, square root of x. How do I undo that? Well, I square this, right? Square root of x times square root of x just gives me x left over, but whatever I square here, I square here. So I get left over x equals 16. And that is my solution. Okay, so my first question is going to be, please solve guided practice number 1, bottom of page 729. And pause the video, and I'm going to catch up with you after you finished it. Guided practice 1. Square root of x minus 7 equals 0. And let me just do this one first. I'll just do part A first. Okay, so my first step is to add 7 to both sides. Step 2, I square both sides because I want to get rid of the square root. And so I get left with x equals 49. That was part A. Let me do part B, just a few more steps. 12 square root of x minus 3 equals 0. Well, my first step is to get rid of this negative 3 by adding 3 to both sides. So I get 12 square root of x equals 3. But I also need to get rid of this 12. So I'm going to multiply both sides by 12, end up with square root of x equals 3 over 12. Well, then what? Well, I need to square both sides because I've got to get rid of the square root. So I end up with 3 squared, which is 9, over 12 squared, which was 144. And 9 over 144 reduces to 1 over 16. And that is the answer to guided practice 1B. Okay, let's look at example 2. Just going to draw some lines here so we don't get confused. I have 4, and this time x minus 7 are both under the radicand. Plus 12 equals 28. I'm going to follow the same kind of steps that I just did. My first step again is to get rid of the 12 by subtracting from both sides. So I get left with 4 square root of x minus 7 equals 16. Next, I have to get rid of the 4. So I have to divide both sides by 4. And so I get left with simply square root of x minus 7 equals 4. Well, I've learned what to do when I get a square root on one side. I just square it, and I square the other side. So square root of x minus 7, whoops, and I did try to take away that square root, equals 16. So I get left with x equals 23. So my solution is 23. Now, if you wanted to check and see what this looks like on a graphing calculator, you would have to set it equal to 0. And so, to do that, we would go back to this equation. So this is on Graphing Calculator just so we're clear on what I'm doing. I'm going to use the equation 4, square root of x minus 7, but I'm going to subtract 28. So I'm going to get minus 16 equals 0. Okay, let's try to clear this and go to my y equals and see if I can enter this equation. So 4 times inside the square root x minus 7. And to undo the square root, I'm just going to do this to signal that I'm at the end, and I'm going to do another operand. Minus 16. So that's what I'm introducing as my equation, and let's see what happens if I graph it. I may have to adjust my window. And I do have to adjust my window because I can't see anything. So let me look at my window. And I'm going to make my x minimum, let's see, let's try minus 2. My x maximum, I'll just change to, I'll leave it, maybe I'll put it to 30. And let's look at my y. My y minimum I'll make, let's see, minus 5. And my maximum, maybe I'll do positive 5. And then let's see what happens. Let's see if I get a better graph. Definitely a little bit better, but I think I could do better than that still. So let me adjust my window. And let me try and see if my x max, I'll make, it looks like it's pretty large, so 40. But it looks like the y's are more narrow, so minus, let's see, I'll leave it at minus 4, and maybe y max will be plus 3. And let's see what graphs. So I need to zoom out a little bit. All right, once more with my window. I'm going to get minus 5 for my x min. My x max I'll leave. And I'm going to zoom way out with my y's and see what happens. So minus 20 plus 20. Much better. Now I have a real graph. I'm going to use my trace function and go up and see where it intersects the x-axis. And I'm just about there at x equals 23 when y is, the y is closest to 0. Yeah, it's between minus 0.11 and minus 0.12, so between 23.24, 22.76, so I can safely say that's 23. And I've proved that through my equation, so I can show it both places. Okay, so that's the first portion, and I'm going to go on and finish 11.3 part 1 by doing examples 3 and 4.